In this rapidly changing digital world, we have entered a new era where risk has become a common aspect of our daily life, and our lack of future prospects only seem to heighten our anxiety. Still, why not seize the moment to forecast upcoming technologies and hope for a brighter future? In this video, we will take a look at life in Korea in 2045, based on the 5 megatrends anticipated by the Ministry of Science and ICT and the Korea Institute of Science and Technology Evaluation and Planning. Let us now embark on a journey to a glimpse into life in Korea in 2045. The emergence and convergence of technologies like artificial intelligence, extended reality, and Internet of Things are pioneering a hyper-connected society. As these technologies are employed to develop new services, there is a growing need for high-performance, efficient, AI-specific semiconductor technology. This is because as we have now entered an era requiring the high-speed computation of large-scale data, we are encountering bottlenecks caused by massive data and facing the issues of increased power consumption. This spotlighted the limitations and severity of the traditional von Neumann architecture. And to address this issue, the development of next-generation AI semiconductors has quickly gained momentum. The solution is process-in-memory semiconductors. PIM semiconductor technology allows for an unlimited data transfer between memory and the processor, dramatically improving performance. Meanwhile, it greatly reduces power consumption, making it a groundbreaking AI semiconductor technology that integrates and converges both the processor and memory. Technologies tailored to create hyper-realities will evolve, driven by the metaverse, based on the process technology that ensures advanced computational performance and specializes in integrating various technologies. The birth of the metaverse, which began in the 2020s, will evolve through advancements in hardware and software such as virtual reality, augmented reality, and mixed reality, to make extended experiences a common occurrence in our daily lives by 2045. We will also have the technology designed to build 3D hyper-reality by collecting data from multiple sensors and transmitting it at ultra-high speed and low latency. So, what will we be able to do if we apply this to industrial and educational settings? In industrial settings, XR can be used to view 3D machine drawings for more precise work. For educational purposes, we will be able to plug into a virtual environment system that allows us to choose education that meets our individual preferences and needs, and experience the desired content without being affected by the constraints of time and space. In the future classroom that exists in a virtual environment, personalized education will be provided through interaction between educators and learners, rather than one-sided teaching by rote. Rapid technological advances combined with a severe climate crisis now pose various risks to our daily lives. Such risks include ever-evolving cyber threats and real-world crimes, unpredictable natural disasters, as well as human-caused catastrophes, such as terror attacks and wars. Especially, the risk of emerging infectious diseases is increasing as climate change threatens wildlife at the same time that animals move into human habitats. With these growing everyday threats, there is an ever-increasing need now for social and health security. Therefore, by 2045, cities will provide buildings and urban facilities with autonomous security robots that combine robots, self-driving technology, detection sensors, deep learning modules, location information, and AI technology to preemptively detect physical and cyber crimes. By integrating these with the existing management systems and networks, we will be able to create safer buildings and cities through integrated operation and management. Moreover, in smart cities built upon ICT technologies such as IoT, mobile services, and wearable devices, building specific technologies designed to counteract natural and human-caused disasters will advance even further. With modular-based temporary shelters and relief facilities, alongside protective facilities against advanced terror attacks, we will be better equipped for the ultimate response to ensure safety and survival. It is important to note that we must not overlook the dangers posed by various infectious diseases. An AI system that automatically scans various data throughout the world will swiftly alert us about the emergence of new or mutating diseases' local soil. Predefined metrics like the degree of risk and spread rates will allow us to assess the degree of pandemic threats globally and regionally. It is one of the indispensable future technologies that will be useful in a system designed to counter the entry and spread of new or mutated infectious diseases with preemptive anti-epidemic measures. Our society is quickly aging with declining birth rates, bringing about many changes. With an aging workforce, there has been a drop in the available labor population and the rise of single households, as well as the advancement towards a more multicultural society, which have also drastically shifted our demographics. Following these trends, cities have consistently evolved and been reshaped under this new paradigm. As we enter a society defined by diverse values and embrace rapid changes in population and urban structures, which technologies might the future hold? First, robotic technology designed to either replace or assist the current workforce will see further advancements. As such, wearable robots that can comfortably be worn like clothing and move according to the wearer's intentions to assist with tasks will become more widespread. They can be used to assist workers or soldiers with full physical capabilities and are also suited to assist the elderly or disabled people who might have limited physical strength. Robotic mobile units that completely replace the existing labor population will also make their debut. With the development of on-site mobile 3D printing systems, instead of assigning workers to hazardous and special sites, mobile units equipped with 3D printing systems will be assigned to move to the location of the components to be repaired and perform stacking and processing flawlessly. The future urban space where humans and robots coexist will be composed of a variety of housing environments, going through the era of a single-person households, unmarried households, and multicultural households. In response, AI-based resident customized systems that create the optimal living environment tailored to the lifestyle of each individual will be applied in the hyper-connected smart city. Individuals will be able to directly manage various data, such as indoor environmental data, health data, and preference data through multiple mobile devices, and reflect any shortcomings in their living environment immediately. While such technologies might enhance our quality of life, in the future society, the loneliness, feelings of isolation, and depression faced by single-person households and older households may still persist as social issues. What if there were robots that help alleviate these issues, coexist with us, and share our emotions? Robots equipped with the technology to sense and infer surroundings, to make independent decisions tailored to individuals will positively impact us as human companions. In the future, we might see every household comprising companion robots, not just replacing labor, but also providing emotional support. Following the COVID-19 pandemic and several supply chain crises, there has been a shift towards prioritizing security, and key nations in the global value chain are now implementing policies designed to reinforce the domestic supply chain. Countries worldwide are deploying various strategies in response to shifting export markets. This includes strengthening non-tariff barriers or restructuring their industrial frameworks. These shifts in the global value chain have altered the traditional roles of nations. Now, we are at a turning point where we even need to reevaluate our perception towards democracy. A core technology for achieving carbon neutrality that continues to grow in socio-economic importance within the global value chain involves the secondary battery. From wearable devices to mobility solutions, eco-friendly secondary batteries are projected to become the primary power source. As personal air vehicles, like flying cars, see great advancements in the coming years, innovative technologies for lightweight secondary batteries with a larger capacity that provide more power will become indispensable. In particular, secondary batteries for electric vehicles, in which Korea stands ahead of the pack, are expected to be an immense help in strengthening the domestic ecosystem. Through super battery technologies that offer more than 1,000 kilometer range on a single charge and a long lifespan that does not require a replacement, we will become central to the global value chain. The display industry, another major industry in Korea, is also set to be a driving force in enhancing the domestic ecosystem and supply chain. A sub-miniature portable holographic display resembling a watch with a screen size of less than 1 inch is projected to exhibit tremendous potential as a future technology. Future technologies such as miniature laser light sources, holographic materials, and compact graphic system will allow us to achieve unprecedented miniaturization. Furthermore, if commercialized, the robust domestic display sector would bolster our national ecosystem as a formidable force on the global stage. Such a shift in the international dynamics will ultimately reshape the traditional roles of nations, driving the development of new communities that allow for diverse communication. By 2045, we will fully engage in public communication with citizens, locals, and central governments through a blockchain-based communication network platform with enhanced security. Online services enabling communication with virtual environments via VR or AR technology will also be widely adopted. Communities evolving in this manner will naturally foster interactions among various members in the society and reshape traditional concepts and the roles of nations, thereby exerting a powerful influence in flexibly developing the perception of democracy. Due to various extreme weather events such as wildfires, droughts, and flooding, more people are now losing their resources and homes. This has increased the need for infrastructure to predict and recover damages, and future technologies are taking the steps to secure new resources and homes to mold our future. First, modeling technologies designed to predict a wide range of disasters will be used as a solution to the damage inflicted by the climate crisis. With a multidisciplinary approach, disasters will be predicted preemptively to anticipate potential social and environmental damages, thus reinforcing our resilience against disasters. This technology will also be associated with countermeasures to minimize large-scale damage through an extended application to the entire globe. One of the emerging grave concerns is the threat of food security due to changing ecosystems. This is caused by decreased crop yields resulting from elevated temperatures, drought, and excessive rainfall. To address this issue, the smart farms, completely isolated from the outside and automatically controlled by internal environment control systems, will deliver optimal growing conditions for crops. By leveraging smart farm technology, we anticipate that systems will be available to predict the harvest yield and nutrient content based on various agricultural data, such as the environment, growth and development, and functional ingredient data. As we embark on developing new alternative resources to combat the climate crisis, one technology that has emerged as a beacon for carbon neutrality is the small modular reactors. With its compact size comes its advantage. They will play a pivotal role in power production. This technology, aside from light water reactors which use water as a coolant, is useful for developing reactors with varying concepts, depending on the purpose, such as gas-cooled reactors and molten salt reactors. This small modular reactor technology may allow to produce cities with zero carbon emissions by 2045. Moreover, we are now at a stage of venturing into space, not just for more resources, but also for additional living spaces. For a potential settlement on the promising candidates like the Moon or Mars, technologies combined with various imaginative concepts are under development. Not only varying technologies to cultivate abundant crops on local soil to support the long lives of spacemen on the Moon and Mars, but also the essential technologies used to construct and operate manned bases, which will enable society to sustain the emergence of a lifestyle similar to Earth. We might see a future where we travel back and forth between cities on Mars and the Moon and Earth. We have taken a look into the anticipated technologies designed to address the numerous challenges laid before us. Furthermore, for a better Korea by 2045, the Ministry of Science and ICT and the Korea Institute of Science and Technology Evaluation and Planning have selected 241 other future technologies awaiting us. Will we be able to truly save our planet in crisis through these new future technologies? Until the day our pleasant imaginations become reality, please remain here with us. And with that, we wrap up our journey to a glimpse into life in Korea in 2045. Thank you.